Alright everybody, this video will serve as a lecture for Chapter 8. You should have read Chapter 8 so that you have a bit of, at least somewhat of an idea, a basic idea of the concepts in Chapter 8. This video lecture should help to flesh those out. So in Chapter 8 now, we're going to deal with inductive arguments. We've so far been looking only at deductive arguments. So first, we're going to need to understand the distinction between inductive and deductive arguments, and that's one of the primary tasks for this chapter, to be able to identify which arguments are inductive and which arguments are deductive. Although there are various differences between inductive and deductive arguments, the primary distinction, and this is important, the primary distinction between the two is in the way that the arguments are evaluated. So the intended evaluative standards for inductive arguments is different than the intended evaluative standards for deductive arguments. And we know by now that the evaluative standards for deductive arguments are validity and strength. When we evaluate a deductive argument, we evaluate it for validity. And we do that because deductive arguments are given in such a way that they're intended to be valid. The relationship between the premises and the conclusion is one in which the premises are intended to support the conclusion in such a way that the conclusion is intended to follow necessarily from the premises. Inductive arguments, however, don't have the same relationship between the premises and the conclusions. So, although a deductive argument is intended to be valid, an inductive argument is not intended to be valid. Rather, the relationship between the premises and the conclusion is merely one of strength. So the reasons given in support of the conclusion are meant to show that the conclusion follows more or less strongly from the reasons, but it does not follow necessarily. Consequently, inductive arguments, because they're not intended to be valid, that is, it's not intended that the conclusion follows necessarily from the premises or the reasons, inductive arguments can be what we call defeasible. They are defeasible. And what that means is the argument can be defeated. So if new information comes to light, new reasons, new premises, it can change the strength of the inductive argument. Whereas deductive arguments are not defeasible. They can't be defeated. If a deductive argument is valid, it will always be valid even if we add new reasons or premises. An inductive argument, on the other hand, since it's only showing that there is more or less strong reason to believe the conclusion, when new information or new reasons come to light, that can defeat the argument. It can make it more or less strong than it currently is. When we evaluate inductive arguments, we evaluate them for strength, and the strength of an inductive argument is one of degrees. So we might have an inductive argument that is weak, we might have an inductive argument that is strong, we might have an inductive argument that is very strong. Deductive arguments are either valid or invalid. It's quite straightforward. But strength comes in degrees. So an argument such as, because the sun has come up every day of my life, the sun will come up tomorrow. That's a pretty strong argument, but it's still an inductive argument. That is, the conclusion doesn't follow necessarily from the premise. The sun has risen every day of my life, therefore the sun will come up tomorrow. Not a deductive argument, not intended to be evaluated for validity. It's not the case that the conclusion follows necessarily from the premise. In fact, the conclusion is not meant to follow necessarily from the premise. The conclusion, the argument shows that we have good reason to believe the conclusion. It's a strong argument that because the sun has risen every day of my life, I have good reason to believe that the sun will rise tomorrow. But, of course, it's possible that the sun won't rise tomorrow. It's a defeasible argument. It's intended to be evaluated for strength, not for validity. We do not intend, with inductive arguments, for the conclusion to be necessarily so, in the way that we intend in deductive arguments for the conclusion to be necessarily so. This might lead you to believe that deductive arguments are better than inductive arguments, but that's actually not really true. even though inductive arguments are defeasible, they can be strong beyond a reasonable doubt. And deductive arguments, although the conclusions, when valid, follow necessarily from the premises, they're not necessarily advantageous or better arguments because it's easier to establish the truth of the premises of inductive arguments. So although a conclusion might follow necessarily from a set of premises in a deductive argument, often those arguments, those deductive arguments, are more difficult to determine the truth of the premises. And we know that in order to know if the argument is sound and thus a good argument, a deductive argument has to not only be valid but also have true premises. So for this reason, inductive arguments, which are the basis of much of our knowledge, are just as good as deductive arguments. So here's an example. Here's a deductive argument. If God exists, then Lassie will go to heaven. God exists, therefore Lassie will go to heaven. This is a valid deductive argument. Yet, it's not clear whether the argument is sound. We would have to be able to say that all the premises are true. So we would have to say that it's true that if God exists, then Lassie will go to heaven. Can we say that we know that that's definitively true? We would also have to be able to say that it's true that God exists. And it's not clear that we can definitively say that that is true. Here's a similar argument, but an inductive argument. 8 out of 10 people believe that God exists. And 9 out of 10 people who believe in God believe dogs go to heaven. Therefore, Lassie will go to heaven. Now, the conclusion in this case, Lassie will go to heaven, the same conclusion as in the deductive argument, is not meant to follow necessarily from the premises, yet it's easier to accept the premises or to prove them true. That is, that 8 out of 10 people believe God exists. We can do a survey. And that 9 out of 10 people who do believe in God also believe that dogs go to heaven. So, in this sense, although in the deductive argument the conclusion follows necessarily, it's not in fact a better argument because we cannot prove that the reasons are true in the deductive argument, whereas we can prove the reasons to be true in the inductive argument. So even though it's fallible or defeasible, the inductive argument is at least as strong as the deductive argument. Now, there are two kinds of inductive arguments that we're going to look at: statistical generalizations and statistical applications. Let's start with statistical generalizations. One of the primary types of statistical generalizations is something like an opinion poll. It's a classic example of an inductive argument. So, because all voters in a voting poll, for example, can't be polled, an inference is drawn from a sample. This is the same form of reasoning used to reach statistical generalizations. So, for example, all ogres that I've ever seen are green, therefore all ogres are green. So we take a poll or a set of data based on a sample population, whether that's people or objects in the world, and based on that sample, we make a generalization about the overall population. So, for example, 65% of introduction to philosophy students at Eastern Michigan are female. Therefore, more females take philosophy classes than males. Now, this is an inductive argument. It's a statistical generalization. Now, this may be a more or less strong statistical generalization. So, for example, if I give you the argument, I flipped a quarter twice and it landed on heads both times. Therefore, anytime I flip a quarter, it's going to land on heads. That's an inductive argument that is based on that is a statistical generalization. I take two sample cases, that's my sample set, and I draw a generalization from that sample. Because I flipped a coin twice and it landed on heads both times, I conclude that the coin will always land on heads. Now, clearly this is not a very strong argument, but it is an inductive argument of the form statistical generalization. Now, imagine that I take a wider set of cases. Imagine I take a quarter and I flip it 97 times. and all 97 times it lands on heads. So I say, because the quarter landed on heads 97 times, I conclude that the quarter will always land on heads. This is the same kind of argument. It's an inductive argument. It's a statistical generalization. Based on 97 cases, I can make a general conclusion that the quarter will always land on heads. But this second argument is much stronger than the first one based on only 2 coin flips. So both inductive arguments, both statistical generalizations, but one is stronger than the other. Now, for any statistical generalization, we have to ask certain questions in order to evaluate it for strength. The evaluation process for inductive arguments is nowhere near as technical as it is for deductive arguments. We won't be doing truth tables, we won't be evaluating for validity. We're going to look at inductive arguments and ask a few questions to determine whether or not the argument is a strong inductive argument. That is it weak inductive or strong inductive? Here are the questions that we want to ask. First, should we accept the premises? This one's pretty basic. We just want to ask ourselves if the premises themselves stand up to scrutiny. That is, are they true and justified premises? Are they true and justified premises? Are they relevant to the conclusion? Is the person giving them fairly reliable? Or do they have reason to lie? Are they completely drunk? Or should we accept the premises at face value? The second question is the sample large enough? This is what got us in trouble with the first argument about the coin toss. If I only flip a coin twice, that's not a large enough sample to make a statistical generalization. Whereas flipping the coin 97 times is a large enough example. So there's no guideline or rule about the number needed for a particular sample size. It really depends on the context. So for example, flipping a coin 97 times is a pretty good sample size. But if we're doing an opinion poll based on the presidential election, if we only survey 97 people, 97 voters, that's clearly not a large enough sample size. Now, the third question we want to ask is whether or not the sample is biased. So even if we have a large enough sample size, it's possible that the sample is narrow in some way and it's only based on a biased population. So, for example, if an opinion poll polls 50 million people, but it only polls middle class and wealthy people and mostly white people, we're likely to have a biased sample. That is, we're not going to come out with a generalization that is representative of the entire population. So we end up with the fallacy of bias sampling. So whenever we poll people of the same sex, class, race, age, political persuasion, religion, etc., it's likely to result in biased samples. So in addition to the sample size, we need to be sure that the sample itself is not biased, that it's representative of the population broadly, whether that's a population of people or a population of a certain set of objects. And then finally, in addition to the sample size and whether or not the sample is biased, we have to ask if the result is biased. That is, even if we get a good unbiased sample with a large enough sample size, we're still at risk of having an argument that is badly interpreted. And prejudice is the main source of bias in science, education, and everyday life. So we can turn a good sample into a biased inference due to our own prejudices in interpreting the data or the sample set. So even with a good sample, the questions themselves can misconstrue the results and therefore bias the argument. So for example, if Target sends out surveys to their customers and says, do you prefer Target over Walmart? And a majority of Target customers say they prefer Target over Walmart, and the conclusion is that shoppers in the United States prefer Target over Walmart, we have an issue of a biased sample, because the surveys were only sent to Target customers. However, if, for example, you survey a good sample size of women and ask them whether their children are smart. And a majority of women report that, in fact, their children are above average in intelligence. And we conclude that most children are above average intelligence. We have a biased result. Because mothers are interpreting the intelligence of their children, the interpretation is likely biased. So the sample isn't biased because we're talking about a variety of children. There's no bias in the sample, but the interpretation is biased because, of course, mothers are going to say their children are above average in intelligence. But it can't be the case that most children are above average in intelligence, right? So what we have here is a biased result. Statistical generalizations is one kind of inductive argument. A second kind is statistical applications, where statistical generalizations go from a sample up to a general claim. Statistical applications take a general feature and apply it to a particular case or set of cases. So, for example, if we know that 94% of Utahns are Republican, and Leisha is a Utahn, we then can claim that Leisha is a Republican. Now, of course, this isn't a deductive argument. The conclusion doesn't follow necessarily, but it's a pretty strong argument. If it's true that 94% of Utahns are Republican, and Leisha is a Utahn, then it's pretty likely that Leisha is a Republican, but it's not necessarily true. Also notice that this inductive argument is not a statistical generalization. It doesn't start from a sample population and make a general claim. It's a statistical application. We start from the general and move down to the particular. So we apply a general claim to a particular person or case. So because 94% of Utahns are Republican, and Leisha is a Utahn, we conclude that Leisha is a Republican. So we've applied something about Utahns generally to one particular Utahn. Right, so this is the basics of Chapter 8. So what you need to know is the distinction between inductive and deductive arguments, and we'll practice that a little bit, but be sure you've read this. And the distinction between the two major types of inductive arguments, statistical generalizations and statistical applications.